All right, here's our video, Algebra 1 Regent questions. We'll be doing algebra questions in Algebra 1, obviously. And I'll just do 10 questions each video. So this is the first video, part 1, just 10 questions you'll see on the exam. These are 10 questions that have appeared over and over again on the exams through the years. So let's get right to it. All right, here's question 1. We'll start with red. Put a little 1 there. Question 1. You'll see something like this, and they'll ask you, which one of these relations, we have 1, 2, 3, and 4 relations, which one is not a function? So make sure you read carefully what is not a function. So if you look at this right away, just look at this one right away, you'll see this is not a function because you need 1x for 1y. It's a good rule to remember. So here's the x, there's the y. The x is always on the left. It's always on top or it's always on the left, as you can see here, x and y. So if you look at this here, here's the x. We have 1x for 1y, so that's working. That's great. But look at this another x right here. There's 2. This 1x has 2 y's, and you can't have that. It's not a function then. Remember the rule, this big rule, 1x for 1y. So, for example, let's say I gave you this one. Let's say I had A, and we had B, and we had C, and that was the X. And the Y, we had, let's say, 1, 2, and 3, and maybe we had 4. So maybe this A was with Y, that 1, and this B was with that 2, but the C was also with that 2. Now let's put them more. And D, let's say, and E. Let's say D was with 3, and E was with 4. So now you don't have 1x. You have 1x for 1y, right? A could be what has its 1y, B has its 1y, C has its 1y. The y can have multiple x's, but the x can't have multiple y's. Just put a big star there. Remember that. So yes, you could have this. This is a function because the y can have multiple x's, but the x can't have multiple y's. Just keep that in mind. Let's go to question 2. All right, now question 2, here we see some transformations, and I'm going to give you a shortcut. So when you see this is a horizontal and a vertical translation. So on the graph, let's just say, get our pen going, let's say that was f of x right there. It's really not important where they are, because you can see in the vertical translation, they're both in the same area, because they have a plus 4 here. So we're really concerned with what's in the parentheses here. So when you graphed f of x, this would have been shifted 2 to the right. It would have been shifted 2 to the right. So remember, when you have to think, this is very important, put a little star. Star in my idea here. When you see a negative 2, you would assume you should go to the left, but actually do the opposite. So when you see a negative in a horizontal translation, go to the right. So you went to the right 2. So if you want to compare g of x would have been to the right 5. So if you want to say how was it shifted, it was shifted what? What do you think? It was shifted 3 units. 3 units to the right. That's what it was shifted. All right, let's go to question 3. All right, question 3. Let's say you had P. Well, no, we went to question 4. Well, why not? We'll just put the number 3 back. There we go, number 3. So let's say we had, well, q, doesn't matter what it is. Let's say a q to the 4th power minus 36. So when you see this, you know you have a difference of 2 squares, because the square root of q4 is q2. And we know the square root of 36 is 6. So we have a difference of 2 squares. So when we have a difference of 2 squares, we're going to make our 2 binomials, and we're going to put our q2 in both. And then it's very important when you see a difference of 2 squares is always a plus minus. Keep that in mind when you're doing this. And again, I'm just giving you shortcuts, and we're going a little quickly because I'm assuming you know most of these questions already. If you need more feedback on this, I have other videos on Regents. So again, it should be plus and minus because you have a difference of 2 squares, and then just put 6 because that's the difference of those 2 squares. Now we can check it. Here's a different color, why not? We'll check it with foil, right? First, outside, inside, last. So the first term times the first term, q second times q2 is q to the fourth power, right? So we have our first one there. The outside term, q2 times negative 6, right? That will give us minus 6q squared. Then we have our inside term, 6 times q squared will give us plus 6q squared. And then the last term will be positive 6 times negative 6, so will give us negative 36. And these two will cancel out. A positive and negative will cancel out in like terms. And we checked, and it came out what we wanted. So if they say, what is equivalent to this expression? This is an expression here. What is equivalent to it? It would be this. All right, now let's go to question 4. Clear that out. All right, so let's say you had a question like this. Get the pen going here. Do green. And let's say it says if f of x equals 4x minus 5, what is f of, let's say, 0? What is f of 0? So all you have to do is plug in 0 for x, right? So it's 4 times 0 minus 5, and we know that's just going to be minus 5. So f of 0 equals negative 5. That's question 4. So again, when you see these questions, they're pretty easy. Just plug in whatever is in the parentheses here. What is f of 0? What if for example, what if it was f of negative 3? Right? That'll be question 5. Number 5. This same thing, what is f of negative 3? So again, what do? Plug in negative 3 for x. So now you have 4 times negative 3 minus 5. So 4 times negative 3 is negative 12. Negative 12 minus 5. And again, you have your calculator here, but, take your time. Don't rush. Remember, this is a negative, it's a minus sign, not a plus sign. So if you remember, keep change, it'll be that. So what is f of negative 3? Negative 17. All right. Okay, number 6. Let's say you had, and we'll keep green. Let's say you had 6x to the 5th power plus 8x minus 3x to the 3rd power plus 7x to the 7th power. What would this be in standard form? How would you write this in standard form? So remember, standard form just means that you're putting them in descending order, the variables and the exponents. Just the exponents. So we should start with 7x to the 7th because that's the highest exponent right there. The next highest is 6x to the 5th. So we'll say plus 6x to the 5th, right, because there's no negative sign there. And then we'll have minus 3x to the 3rd, and then plus 8x. So that'll be in standard form. So again, standard form is in where the exponents will descend, not ascend, descend. All right, let's do number 7. All right, number 7. Change the color, why not? So let's say you had a domain and range box, or x and y box. You had an x here, and then you had f of x. And we made a box. That's a little crooked. And we had 0, 1, 1, 3, 2, 9, and 3, 27. All right, doing a little leaning tower of Pisa today. So what type of equation is this? Is this a linear equation? Is it an exponential function? What type of function would this be? Well, and is it a growth? Is it positive? Those are the questions. Well, we know if we look at y is increasing each time. So we know this would either be positive, it's going to be positive, and it'll be a growth. We know that. But is it exponential or is it linear? So look at the x. Do you see a pattern here? So we have 3. 3 cubed is 9. And we know 9 cubed is 27. So you're seeing those exponents right there. So this will be an exponential growth. It's growing. It's an exponential growth. So this will be an exponential function. Just going back to that question, let me just write it again. 0, 1, 1, 3, 2, 9, 3, 27. So you do see an exponential growth here because 3 cubed is 9, 9 cubed is 27. You don't see a constant rate of change. You see this growth happening. So just in general, you see something like that, it's exponential. You see something, a straight line, it's linear. Let's go to question 8. So let's use blue again. What if we had these radical questions? Let's say they want to know which one below is rational. We want to know which radical is rational. So let's say I gave you, we had the square root of 2 plus the square root of 2. That's one of them. And then we said maybe 5 times the square root of 5. And number 3, we said maybe square root of 2 times the square root of 18. And number 4, let's put 3, the square root of 2, and let's put another plus 2 square root of 3. So when you're looking at radicals, think of them also as variables, right? So let's say, for example, I had x plus x. So x plus x is just 2x. So if you had square root of 2 plus the square root of 2, well, that's just 2 square root of 2, right? That is not rational. So we'll use our red ink here. We'll say, no, that's not rational. So 5 times the square root of 5, that's just 5, what? Square root of 5. That's all it is. So that's not rational. And number 3, let's do 4 first. This 3 square root of 2 plus 2 square root of 3, you can't add when they're different radicals. The same as if you had 3x plus 4y. What can you do with that? You can't do anything with it. So this is not rational. So this is the only one that's rational. So this would be square root of 2 times the square root of 18, which is the square root of 36, which is 6. And that's a rational number. All right, here, let's do number 9. I'll use purple. What if we had, let's say you had 3a plus 7b is greater than 2a minus 8b, and they said solve for a. Solve for a. So let's solve for a, right? So here, if we want to solve for a, let's get rid of the b's. So we can minus 7b on both sides. Really doesn't matter which b you use. So that'll give us 3a is greater than 2a minus 15b. And then we just need to get the a on the other side by minusing 2a on both sides. Whatever you do to one side, do to the other. And then we're just left with a. A is greater than negative 15b. That's solving for a. All right, the last question today. Okay, let's say we had, and we'll use that color, why not? Let's say we had 5x squared. 5x squared equals 180. How would we solve this? Well, we can divide out that 5, and now we have x squared equals 180 divided by 5. Use your calculator. That's 36. And then we just get the square root we'll square root each side. Just square root each side when you see that square root. Square root of x squared is x. That's what you're looking for. And the square root of 36 is 6. So that's the first 10 questions. Next video, we'll do 10 more. All right.